In this question, we have a man being lifted from a zero velocity, so the initial velocity is 0 meters per second. He's been lifted, rescued. The tension in the cable is 3,600 newtons. The man's mass is 75 kilograms, so his weight is 735 newtons. And as he is lifted, there is an air friction of 1,540 newtons acting on him. Now, this is a work energy question. And they ask us to calculate the velocity of the man by the time he has been lifted 12 meters up into the air. They ask us to use energy principles to calculate this velocity at the moment he reaches 12 meters. Now, to identify the forces acting on the man, tension is a non-conservative force. Weight is a conservative force. Air friction is a non-conservative force. And it leads to, these forces leads to a change in kinetic energy as well as a change in potential energy. Now, if we go to our data sheet, there are two paths, or maybe more, to follow here. The first one that I think of using is the work done by the non-conservative forces would cause a change in the kinetic energy of the man as well as a change in the potential energy of the man. Now, the non-conservative forces we have identified as tension and as air friction. So, the work done by the tension is tension times the height that he's been lifted. I can use delta x here, cos the angle between the tension and the displacement, which is 0, plus the work done by the air friction is the air friction times the height that he is lifted times cos 180 degrees. Those are our two non-conservative forces that leads to a change in the kinetic energy, which is a half times the mass of the man times his final velocity squared minus a half times the mass times his initial velocity squared, plus the change in the potential energy. That is, I'm going to combine them because the initial height is 0 and the final height is 12. So it is mg hf minus hi. Now for the substitutions. 3,600 times 12 cos 0, which is 1, plus 1,540 times 12 cos 180, which is minus 1, equals a half times 75 Vf squared, and his initial velocity was 0, so that falls away, plus 70, I can say 735 times 12. Righto, so now we do our Cassiophying, and some people like to do each one individually, but I'm going to combine them. So 3,600 times 12 cos 0, which is 1, and this cos 180 would be minus 1, so it is minus 1540 times 12. Then I'm going to subtract to this minus 735 times 12. I'll get the answer 15,900. So all this, a half of 75 VF squared is 15,900. Okay, which we can take, I'll multiply by 2 and divide by 75, doesn't matter as long as you get the maths right, times 2 divided by 75, and then take VF squared is 424, so VF is the root of that, which is 20.59 meters per second. That takes us to that.